Yeah. Hello, everyone. Good morning. Are you able to hear me?
Yes, yes, Venkat.
Okay. Okay. So let's start our today's discussion. So in our last session, we have discussed about Spark introduction. So what is Spark? We have seen how it got evolved, right? So how to create the cluster in Dataproc, and then how to open or check the Spark related things in GCP Dataproc. So we have seen a little bit introduction related to Spark framework. Okay, so today we will go a little bit deeper into the Spark internals. Okay, so how Spark works, what is the
Okay.
Spark architecture, right? So how it will process, right? So how it will process the data internally, how the architecture works. So everything we will discuss today, and so I request everybody to pay attention for today's session because this is a Spark architecture session. So we will be discussing the deep internals of Spark, how actually it works, how to understand the Spark behavior. So everything we will see today. Okay. So let me quickly share my screen. Before going to that, anybody have any questions or queries with respect to your exploration, right? Anybody have any confusions? So you can ask. Okay. Hope everything is clear. So let's quickly jump into our today's session. So today we will discuss about the Spark architecture. In our last session, we have seen how different it is from MapReduce, and how actually Spark process the data, right? So Spark is a distributed parallel in-memory data processing framework. Okay. And remember one thing, Spark doesn't store any data. Be very, very clear. Spark don't have any storage layer. We have to maintain external storage layer for Spark, meaning the data maybe in GCS, okay? The data may be in Hadoop file system. The data may be in AWS S3. So the storage will be in some different place. Be very, very clear. We use Spark framework to process the data. We use Spark framework to process the data. Be very, very clear. Okay, only for data processing. Okay, only for data processing. It is big data processing framework. Okay, now, okay, so what will happen? So initially, when let us take an example. When we submit a request to the Spark saying, "Hey, I have 100 GB data in GCS. I have written a logic in Spark to process it, to process 100 GB data, and then to write it into BigQuery. This is my logic. Okay. So now when I submit it into the cluster, when I submit it into the cluster, we need to submit the job, right? So we write a Python code or a Java code or some other Scala code or whatever it is. So we write it and then we submit to the cluster, right? So in Spark, right, we need to understand few vocabularies, right? So one is driver, right? One is driver. Another one is cluster manager. Okay, cluster manager or resource manager. We'll call it as cluster resource manager. We call it as, and then worker nodes, executors, tasks, DAG. So these are some vocabularies that you need to remember with respect to the Spark architecture. Okay, in interviews you mostly face this question. Okay, so explain about Spark architecture. Okay, so how Spark works in a distributed fashion. Okay, now this vocabulary is very, very important. Job, and then tasks, and then worker nodes, and then driver program, cluster resource manager. So these are very important. Okay. Now, what will happen? So, when we submit a job to the cluster, the Spark framework, how it executes, okay, how it executes internally. So, we know in a cluster, we have a master node and we have multiple worker nodes. Okay, now when you submit the request, it will go to the cluster node. When you submit the request, it will go to the cluster node. In the cluster node, first it will launch a program called driver. Okay, the driver service, it is a JVM service, it's a JVM process, it's a process that will run for that application that you submitted. It will launch the driver program. Okay, that driver program will understand your Spark code. Okay, and it will generate a DAG. Okay, it will generate a DAG. DAG means direct acyclic graph. Be very, very clear. DAG means direct acyclic graph. So what it will do, inside DAG, we will be having the graph of all the transformations that we have written, right? So first we have written a filter, and then we have written a join, and then we have written a case when. So and then we have written a write. Okay, so these are all the transformations that I have there, I mean, that I have written in my Spark program. So your driver service or your driver program will split these transformations into tasks. Be very, very clear. Will split these transformations into tasks. Okay. Now, how it will split into tasks? In the form of DAG, it will generate. Okay, in the form of DAG, it will generate. Direct acyclic graph is a combination of jobs, stages, and tasks. Be very, very clear. Okay, so when you have a driver program, this driver program in the master node will generate this DAG first. Okay, inside the DAG, you will be having jobs, you will be having stages, you will be having tasks. Okay, what are jobs, what are stages, we will see later, but for now understand, your driver program will split your code into the lower granularity called tasks. Okay, once it has generated the DAG, then what it will do, your drive program will go and communicate with your resource manager. So resource manager is a service. Cluster resource manager is a service that will be running 24/7 in your cluster, and it will manage entire cluster resources. Okay, so when I say resources, it may be RAM or compute, two things. When I say resources, it will be RAM and then the CPU cores, two things. So the driver program, once it derived your actual physical code to the tasks, then it will go and ask your cluster manager, hey, resource manager, I want to run this job, so please give me or please allocate these many resources to me. Okay, then cluster manager will check the cluster resources, and then it will negotiate with the driver program. Hey, you are asking these many resources. If the resources are available, then cluster manager or resource manager will launch those tasks. Okay, will launch those tasks. But if the cluster resources are not available, some other jobs are running in the cluster already, and you are requesting, your driver program is requesting more resources, then your cluster manager will negotiate with the driver program saying, hey, see, you asked 10 GB RAM, but unfortunately I don't have 10 GB, I have 5 GB. I'm launching the job with 5 GB. So it will negotiate with the driver program, and then what it will do, the tasks, right? So the tasks will be triggered once resource manager identifies the worker nodes. uh, okay, so these workers are free. Then what it will do, it will launch the containers in it. Okay, the containers meaning the executors. It will launch the executors according to the resources requested by the driver program. Okay, so now inside these executors, these tasks will be launched by your application master. So there will be a separate service that will be running in, and then that application master will be launching all these tasks in your containers. Okay, now what will happen, your entire processing logic will be splitted into tasks, and these tasks will be executed by your executors. Executor is again a JVM process. Okay, like your driver process, like your resource manager process, executor is also a JVM process, but executor service will run in a worker node, driver service will run in a master node. Okay, so your driver program will split your code into tasks. Okay, and then your resource manager will allocate the resources or will launch the containers according to the resources. Okay, now executors are the services that will run in the worker, and these executors are responsible to execute the tasks. Okay, these executors are responsible to execute the tasks. Now, once the tasks are completed, these executors will perform whatever the right, whatever the action that you have given. So these executors will perform that particular task. Now your processing logic will be splitted and your data will be read and uh, distributedly it will be processed by all your executors. Okay, now how it will read the data in a distributed fashion. So let us take an example. You have 100 GB data in your GCS, and you're reading it from the Spark. Now Spark will create the partitions internally. Okay, now once we have this understanding, then we will go to the reading of it. Okay, how data distribution will happen in Spark. But the internal processing involves driver, resource manager, executor, task, okay, and then DAG. Okay, you need to understand these things. When we go and submit a Spark job, then I will show you clearly what is DAG, okay, what is job, what is stage, right? So your job is a particular part of your Spark code. Be very very clear. Okay, so let us take an example: 5 lines, 6 lines, 10 lines. So a lot of one you have written 5 transformations, and then after that you have written 10 transformations. So it will chunk your transformations into jobs. Okay, each transformation or else each processing logic, depending on its complexity, it will create the stages. Okay, under one job you will be having multiple stages. Okay, under one job you will be having multiple stages. Under one stage you will be having multiple tasks. Be very very clear. Okay, under one stage you'll be having multiple tasks. So job is group of stages, stage is group of tasks. Be very very clear. Okay, now once you have the driver program launches, or driver program derives this DAG from your Spark code. DAG means direct acyclic graph, guys. So direct acyclic graph means it's a physical execution plan. Okay, how your Spark code needs to be executed in the cluster. That's a physical execution flow of your transformations. So first the filter transformation, and then the join transformation, and then the right transformation. So this is a chain of transformations. Actually, it is the graphical physical execution flow. Okay, it is a graphical representation of your actual Spark program. Be very very clear. Okay, now once you have this physical execution, now in any SQL database or any of the SQL things, right, we have a logical plan and a physical plan, correct? So once we submit our query internally, there will be a logical plan that will be generated, and there will be a physical plan that will be generated. Here the logical plan would be the lineage graph. Okay, so the lineage meaning this one. Okay, one data set, another data set, and then the combined data set, and then the final data set. So it's a chain of your data sets. right? Internally, it's a chain of your data set. So the lineage from one source data set to the final data set, after the transformations, you're deriving one data set, and then you applied another transformation on top of the data set. Again, you derived another data set. So it's a chain, right? So that chain we will call it as a lineage. Okay, and the DAG is a more detailed form of the lineage, meaning more detailed transformation flow. How this lineage should be executed in the cluster. So that is what DAG, direct acyclic graph. Okay, so on a high level fashion, you try to understand. Don't go in depth, because when if you want to go in depth, you need to know how Spark works, right? So that we will come to know when we write a Spark program, and when we understand internals of Spark vocabulary or naming conventions, right? But now on a cluster, how Spark architecture works, that's the only thing that you need to understand. Okay, when you submit a Spark job to the cluster, there will be a driver service that will be running in the master node. And that service, what it will do, it will take your Spark code, it will generate your DAG. In the DAG, what we will be having jobs, stages, and tasks. Okay. And then once I have the tasks ready for this particular Spark code, your driver program will negotiate with the cluster manager or resource manager and ask for the resources in the cluster. So your entire cluster resources will be managed by your resource manager. Okay. Once resource manager agrees upon the resources availability, then what it will do, so your driver program launches the application master service first in one of the containers, and that application master service will will launch all the tasks to the executors. Okay, so we will see that in detail. So simply on a simple note, this is how it works: your resource manager and then your executors. Inside the executors, your tasks will run. Okay, that's simple architecture of your Spark. Okay, now let us see what is there in Spark, right? So Spark is a data processing framework, we know, and there are few APIs that Spark is providing to process your data. Okay, so to process your data, Spark is coming up with few APIs. Okay, first one is Spark Core. Okay, Spark Core means you will be working with RDDs. Okay, RDD is a API that has been provided by the Spark, like you have table in RDBMS, right? Some object needs to be there to hold the data for processing. That objects in Spark, we have three types of objects. One is RDD, data frames, and the data sets. Okay, data frames and data set. Three types of objects are there, or three types of APIs that Spark is providing for us to process the data. Okay, and here if you see in Spark Core, you will be working with RDDs. Okay, you will be working with RDDs. In Spark SQL, you will be working with data frames. Be very clear. Okay, okay. In Spark, you'll be also working with streaming data. Spark supports streaming, real time streaming of data. You can develop streaming applications also in Spark. And Spark also support machine learning. If you want to write a machine learning code and if you want to submit it to the Spark cluster, yes, it is possible using Spark mlib. Okay, and Spark supports graphics and then external packages. So these three are machine learning packages. So we are not going to touch them. But for us, Spark Core and then Spark SQL, Spark Streaming. So these are important. Okay, so that is something that you need to understand. Okay, so here the language support, the programming language support, Spark supports, Scala language. You can write Spark programs in Scala. You can write Spark programs in Java language. You can also write Spark programs in Python. So Spark supports three flavors of programming technologies, and then it also supports R language. So R is a data science or machine learning based language. It also supports R language. Okay, so now this is the Spark architecture, and then how actually the Spark is giving you the data processing features. So it supports Spark SQL, so which is a data frame based API, meaning if you want to process structured data, then you will use Spark SQL. Be very, very clear, or data frame API. If you want to process unstructured data or semi-structured data, then you'll use Spark Core, because RDDs are one form of APIs from Spark where you can process text files, log files, right? So data frames are the pure structured APIs. If you have proper data like CSV, Parquet, Avro, uh, JSON, so if you have these kind of file formats, then you can use data frame APIs from Spark. Okay, so this is a Spark outlier of how it works and how what are the things that it will support, right? So let's quickly move on to the internals of RDDs. Before going to that, I just want your inputs. So anybody have any confusions here or any questions? You can speak out.
No.
No.
Okay, okay, fine. So, as I have already told you, so first we'll be discussing about Spark Core. Okay, Spark Core, and then we'll be discussing about Spark SQL. So these are the things that we'll cover. Okay, so Spark streaming. If I have some time, we'll discuss it. But if I mean if we don't have time, you try to explore it. Okay, so let's discuss on the Spark core. So Spark core is all about your understanding of RDDs, okay, and creating RDDs, transformation of RDDs, and then actions, persistence. So these are all the things that we discuss in a typical Spark core session. Okay, so let us quickly understand what is RDD. Okay, so RDD meaning resilient distributed data set. Okay, resilient distributed data set. Okay, so when you're actually working with data, right? You have a CSV file. Okay, you have a CSV file. You want to process the data into Spark. Okay, when you want to do that, Spark should understand. Okay, you need to read the data into Spark, right? You need to read the data into Spark, and then while reading, Spark will create partitions internally. So it will chunk the data into multiple partitions, and then it will process. So see here, it chunks and then it will process. So the data will be distributed across multiple different executors. Be very, very clear. Your data, your input data will be distributed across multiple different worker nodes or executors. Okay. Now, once you combine the data set, then we'll call it as RDD, resilient distributed data set. Okay, so your input data will be splitted into multiple different worker nodes in the form of partitions. Okay, and those partitions will be executed by your executors. Okay, so your executors have tasks, correct? So that task have the logic. Okay, that task have the logic. Now when you read this data, your executors have the partitions of the data, chunks of the data. Okay, now what will happen? Executors, on top of the partitions that they have, they will execute these tasks. Okay, they will execute these tasks. Now, your resilient meaning fault tolerant. Okay, fault tolerant. For example, you created one RDD from a text file. Okay, from a text file you created one RDD, and then what will happen, that from that RDD you transformed, and then you created another RDD, and then another RDD, and then another RDD. Okay, in between, if any RDD got lost, okay, Spark can able to recompute that RDD from the parent RDD. That is what fault tolerant. Okay, fault tolerant meaning, if any RDD is lost in between, that RDD can be recomputed from the parent RDD. Okay, that is the fault tolerant. So, resilient distributed data set is a Spark API which will be used to process our data. Okay, which will be used to process our data. Is another API which will be used to process the data. Okay. Similarly, data set is another API which will be used to process the data. So there are three APIs from Spark by using which we can process the data. Okay. So the first thing is RDDs. Okay. RDDs meaning resilient distributed data sets. Resilient meaning fault tolerant. Fault tolerant meaning if you have chain of RDDs, and then in between if you lost any RDD, it can go to the parent RDD and recompute the RDD based on the transformations that we have done. Okay, that is what resilient meaning. Distributed meaning, it's a distributed. The data will be distributed across all the executors so that it is distributed. And then end of the day, if we combine all that partitions into single RDD, that's a data set, right? So that's what resilient distributed data set. Okay, so we will understand these RDDs. Okay, we will see how to create RDDs, right? Let us say from the input data how to create RDDs and how to apply transformations on top of the RDDs, right? And then we will see how to write RDDs output to files, right? So these are all things we will explore one by one. Okay, but try to understand, we just started with the Spark based processing. Okay, so meanwhile let's create the cluster, and then we will try to understand how actually we can work with RDDs. Okay, so when you are working with RDDs, so you need to understand few terminologies. Okay, when you are working with RDDs, you need to understand few terminologies. Okay, so here if you see your Apache Spark or Spark RDDs are resilient in nature. So if data in memory is lost, it can be recreated. Be very very clear. Okay, all your RDDs partitions data will be in RAM. Be very very clear. Once you create the RDD, so it will be in RAM. Okay, so you apply the processing logic, it will run in the RAM itself. Okay, so distributed can run on multiple machines because your data set is distributed, so it will be running on multiple different executors or worker nodes. Okay, and data set, it's a collection of data again, right? So multiple partitions are there, and it's a collection of data. Okay, now once you create the RDD have few properties. Okay, RDD have few properties, and it is immutable. Okay, the first and foremost property is immutable, meaning so once you create the RDD, you cannot change it. Okay, you cannot change it. Okay, so that is the property, because if it is there in the disk, right, you can change, but once it loaded to RAM, you cannot. Okay, so you can create the new RDD always, but you cannot change the existing RDD. You cannot change the content of existing RDD. You cannot update the content of existing RDD. Be very, very clear. You can create the new RDD. Okay, you can apply the transformation and then you can create the new RDD from RDD, source RDD. But you cannot go and update the values in the source RDD. That is what the property will call it as immutable. Okay, immutable. Okay, lazy evaluated meaning. See here, you have two RDDs from the external world, and then you applied the transformations on top of the RDDs, and then you created few another RDDs, and then finally you are triggering an action. Okay, so here transformation and action. So these are the two vocabularies that you need to understand when you are working with RDDs: transformation and then action. So not only with RDDs, even with data frames also, you need to know the transformations and actions. Okay, so transformation meaning, it is the kind of operation which will generate the new RDD. Okay, which will generate the new RDD. Okay, action meaning which will return some result. Okay, which will return some result. So you need to understand these two terms: transformation and action. Transformation and action. So these are the two things that you need to understand when you apply a transformation. Okay, transformations are, there are a lot many transformations. We have join, we have distinct, we have intersection, union. These are all transformations only, right? And we have a lot of actions, right? So when you apply a transformation on top of the RDD, it will generate the new RDD. Okay, when you apply action, it will return the value or it will return the result. Okay, so these two terminologies are very, very important. Okay, now here if you see lazily evaluated, this property we need to understand. Okay, lazy evaluated meaning, your RDDs, when you apply the transformations, your Spark program doesn't trigger. Okay, it won't run at all. Okay, you read a text file into RDD, and then you applied transformation 1, it will create RDD2, RDD1, and then apply transformation 2, it will create RDD2, apply transformation 3, it will create RDD3. Okay, you have RDD1, RDD2, RDD3. But it won't compute, it won't start the processing, it won't start the execution. Okay, it will note down those steps. Okay, but when you trigger an action, okay, let us take an example. You at the end, you have written the final RDD2 file. If you are not triggering an action, your Spark program only check the syntax, that's it. It won't trigger the actual processing. Okay, that is what the lazily evaluated property. Lazy evaluation meaning, when you trigger an action, then only your program will start executing, or your program will start processing your data. If you're not triggering an action, your Spark program won't start at all. It will just check the compilation errors and then it will come out. Okay, that is what the lazily evaluated property. Okay, so and then similarly the type inferred. So the type inferred meaning, RDDs are type inferred. Okay, so type means, so they can detect the types of your data sets. Okay, they can detect the type of your data sets dynamically. Okay, so you can infer your data types from the data itself. Okay, you can infer your data, sorry, you can infer your data types from the input data itself. Okay, so that is what type inferred meaning. Okay, so you don't need to declare any schema or data type as such. Spark can automatically read the types of it, and then it can detect. Okay, so this is a about RDD's introduction. So properties of RDD and what is RDD. Okay, and let us understand here. If you see, if anything we got missed, so I don't think we have discussed everything. We have. We have seen what is Spark, and then we have seen its architecture. So once connected, Spark required executors on nodes in the cluster, which are worker processes, okay, that runs computations and store data in your application. So next, it sends the application code to the executors finally, and then SE sends the tasks to the executors to run. Okay, so here, if you see the Spark context, okay, Spark context, in older versions it is Spark context, but in newer versions it is Spark session. Okay, Spark session. So previously we have a driver program, right? So master service or driver service that is running in the master node. So that service is the entry point for your Spark program. So the entry point will be the Spark context, okay, or Spark session. So that a session object is needed when you want to run your Spark applications. You need to create the Spark session. Okay, your Spark session holds all your Spark environment configurations. Okay, and then from the Spark session only you can create your data frames. Okay, from the Spark context you can create your RDDs. Okay, Spark context is your Spark core entry point. Spark session is your Spark SQL entry point. Okay, so you need to start with the Spark context only when you are working with RDDs. You need to create your Spark context, and then you need to create the RDD from the Spark context. Okay, because the inbuilt methods are under Spark context with respect to RDDs, but the inbuilt methods with respect to data frames will be under Spark session. Okay, and the single key or the single entry point for Spark code will be the Spark session. So any Spark application that we will be developing, okay, you will be creating a Spark session first. That is an object. So when I say Spark session, it's an object, guys. Okay, which holds your entire Spark environment configurations. Okay, Spark environment configurations, meaning your executor memory or your driver memory or your executor cores, driver cores, everything. So your Spark session holds that is a single entry point for entire your application. So that will be only one for a typical application. Okay, for one job you will be having one Spark session. That is the object that you need to create. Okay, that is the object that you need to create. Okay, so here if you see SC is Spark context. Okay, so similarly you will create Spark session. Okay, Spark session is an object. So that is something that we will create, and we will try to work with that Spark session. Okay, so the thing that we need to understand here, guys, so we have seen what is the Spark architecture today, and we have discussed what are RDDs, and what are the properties of RDDs. Okay, and we have seen some terminologies called transformations and actions, right? So in Spark we have different kind of transformations. Okay, and we have different kind of actions. Okay, it's different types of actions also there. So here if you see map, flat map, filter, map partitions with index, sample, union, intersection, distinct, right? Group by key, reduce by key, aggregate by key, sort by key, joins. So these are all different transformations. Okay, and the actions include reduce, collect, count, first, take, right? Take sample, take ordered, save as text file, save as sequence file, save as object file, count by key. So these are all actions, guys. Okay, so you need to understand what are transformations and what are actions when you're working with Spark. Okay, so how a typical a small Spark program will be there, right? So RDDs can be created in two different ways. Okay, One is using the parallelize existing data collection and creating RDD from the external file. Okay. For example, I have a list of elements, or I have a data structure or data collection. From that data collection, I can create RDD. That is one way. And the second way is from the external file, you can create an RDD. Okay, so here the programming language is Scala. Don't worry. So we'll practice these codes in Python. Okay, so here if you see, I have a list of elements. 1, 2, 3, 4, 5, 6 is a list of data. Okay, when it is a normal variable, right? So it's, if you see the Python list, right? So you created a list in Python. So once you created, the elements will be stored in that variable, right? So the memory will be allocated from the kernel machine where actually your Python is installed. So from that machine, your memory and your compute will be allocated for that variable. Okay, but when you create an RDD for that data collection, your elements will be distributed in multiple different executors. Be very, very clear. Your list of elements will be distributed in multiple different executors. Okay, so meaning your list will be distributed in dist data variable, not in data variable. Okay, in data variable, all your elements will be stored in a single machine. Okay, because that's a normal Python variable or Scala variable. But when you see the dist data, you created a RDD from the actual data collection. See here, sc dot parallelize. So parallelize is a method in Spark that we will use to create the RDD. Be very, very clear. To create the RDD from a data collection, it may be list or tuple or a set, right? So we use we use parallelize method to create a RDD from a data collection. Okay, from a data collection. So using parallelize is one way of creating your RDDs. Okay, once you create the RDD, the dist data variable is distributed across all your workers. Okay, meaning the data which is there in the dist data variable, which are 1, 2, 3, 4, 5, right? So this will be splitted and stored in multiple different executors. Okay, now when you apply the logic, or when you apply the processing on top of that list, what will happen? All the executors will run that logic parallelly on the chunk that that executor have. Okay, so that is the logic that you need to understand. So the distributed parallel data processing. Okay, distributed parallel data processing. So similarly, you can create your RDDs for a list of strings, list of integers, right? So you can just use the parallelize function. So Spark context is the root or entry point for your Spark framework. Okay, so it will start here only. It holds all your environment configurations. Okay, so now in our latest versions, we the Spark context is available under Spark session. Okay, first you need to create the Spark session and then your Spark context. Okay, we'll see that in our practicals. Okay, but for now, try to understand we have two methods of creating RDDs. Initially, three methods. One, using parallelize method, we can create RDDs from the data collection. Using text file method, be very, very clear. There is a method called text file. Using text file method, we can create RDDs from the external files. Let us take an example. You have a text file, you have a log file, you have some other file in the storage or GCS or wherever, right? So if you want to create RDD from that file, you will use a method called text file. So this is the second way of creating RDD. Third way is applying the transformation on one RDD. So three ways. So You can create RDDs in three ways. So in interviews, interviewer may ask you how many ways are there to create RDDs. So you can say three ways. One is parallelize. By using parallelize, we can create RDDs from the data collections like list, right? So and the second approach is using the parallelize function using this text file function or method by using which we can create RDDs from the external files. Okay, and the third way of creating RDDs is applying the transformation on one RDD so that it will create the new RDD. Okay, so these are the three ways of creating RDDs. Okay, so simple see here the logic I mean this is all Scala syntax, so you don't need to worry about it. So you need to concentrate on the first logic, right? Sc dot text file, and you are processing the log file, you are passing the log file. And here if you see, you are creating the Spark context. Okay, new Spark context, it's a library, guys, it's an object creation, that's it. It's not a very big thing. Okay, only two lines of code. You will set the configuration, and then you will create the Spark context object. Similarly in Spark session also we'll do the same. Okay, so once you have that entry point, by using that entry point you will create the RDDs. Okay, and see here I'm just saying the cache, which will load the data to in memory. Okay, uh, so if you are not using the cache, what will happen? It will load the data partition by partition, but if you are using cache, it will push everything once to the in memory. Okay, see here you are applying the filter logic on the RDD1 log data. Okay, log data is your RDD, and you are applying the filter logic. Okay, and see here, and this is a syntax, right? In Python we can change this syntax. Okay, and then similarly your next filter, right? And you're checking the uh, count of occurrences of B, right? Occurrences of A. So that is the num A's, num B's variables, right? So similarly, when you, because you called the action here, count is an action, right? So it will execute, it will start loading the RDD and then filter, it will start executing all these things, and then it will get the value. So count is an action, so which will return the result, right? So that result will be stored in these variables, and then finally we are using those variables. So on a high level, try to understand how we are just writing the logic. Okay, so here if you see, your Sc is your Spark context, and from the Spark context you used text file method to create the RDD, and on top of the RDD you are applying the transformations like filter. Okay, so and then once you have the filter transformation, you are applying the action called count. Okay, so that the returned data will be stored in the variable. Okay, so here if you see, the line dot contains is the logic. Okay, so and then you are applying the filter on the RDD. So this RDD is a distributed, guys, and this filter is a transformation that will execute on a distributed data set on multiple executors. Be very, very clear. So filter is a task, and this task will be sent to all the executors. Now that task will be executed on the chunks that executors have. Let us take an example. This log data is an RDD, and this RDD has splitted into multiple different executors or multiple different workers. Okay, now what will happen? Your log data have 100 GB, and this 100 GB will be splitted into 10 GB, 10 GB, 10 GB, 10 GB, 10 GB into 10 executors. Okay, now your filter is a task. Okay, now that filter will be sent to 10 GB, 10 GB, 10 GB, 10 GB parallelly. Okay, now all your executors will execute that filter task on top of the 10 GB data that they have. Okay, that is the core agenda or core idea of Spark. Okay, now your data is distributed, and your processing also is distributed, and processing is happening in the parallel fashion. So because of that reason, it is pretty much fast. Okay, because of that reason it is pretty much fast. But when you use Python or when you use any database SQL, right, what will happen? Your processing power is limited to that machine. Okay, but when you are using Spark, your processing power is distributed across multiple different machines. Okay, that is the importance of your Spark. Okay, now working with RDDs is the next session for us. So today we have seen the introduction to the RDDs. Okay, and architecture we have discussed. So what is Spark architecture, and we have seen what is RDD, right? So that's where we'll stop today's session. So tomorrow we will see the practical things related to RDDs, how we will write the Spark program using RDDs, and then how we will run it in Dataproc, right? So all these things we will see tomorrow. Okay, so anybody have any questions in today's session? Any question? Okay, so you just try to go and explore the content. If you have any confusions, you can always go and explore about Spark in internet. You'll find lot many things. So I'm just giving the introduction part to it. Okay, so we still did not enter into the actual Spark programming. Okay, so you can pretty well go ahead and explore about architecture. You can get much more detailed content in the internet also. Okay, if you're feeling confused. So and then tomorrow we will work with RDDs. Okay, we will see different RDD based methods. So we have Spark, pretty good Spark documentation we have. Okay, so see here RDDs, right? So this is the very good documentation of RDDs. Okay, so here you can go through each and every operation of RDDs. Okay, so they have given very good documentation. This is the official documentation. The latest version of Spark is 3.5.2. Okay, and if you see, you can find all the detailed explanation of your Spark uh, transformations and actions, right? Even data frames and data sets, right? Everything you can see. So the PySpark is something that we are going to explore. Okay, so we'll see RDDs based programming and we'll see data frame based programming. Okay, so where is this? Yeah. Okay, so let us start practicing your in Spark from tomorrow. Okay, we'll try to write our Spark programs from tomorrow. Okay, and make sure you have you know how to create the data pro cluster and what is a cluster, machine types, right? So all these things you should be aware. Okay, so let us quickly let us start our practicals with Spark from tomorrow. Okay, that's all I have for today, guys. You can go through the documentation of the Spark also, so you can see the overview, right? A unified engine for large scale data analytics, right? So you can install your Spark also. You can download and install in your local machine also. That is also possible. Okay, so but we are getting that in built into our data proc. We'll use that data proc for our practicals. Okay, you can pretty well follow the instructions, like if when you go to any YouTube or something, you can search how to install Spark, right? So you can set up your Spark in your local also. Okay, so but for us, we will be using data proc environment. Okay, we'll be using our data proc environment, so we don't need to set up the local environment. But anybody interested to learn, you can pretty well go ahead and explore this mid content so that you can install your local Spark. I don't know whether I've installed previous class. Let me check. Okay, so it's not set up properly. So you can pretty well install in your local also. Okay, so that's all I have for today, guys. So thank you so much for joining. Once again, we'll connect back on tomorrow. So we'll start practicals on Spark RDDs. Okay, thank you.
Thanks.
Thank you.